I'm by-Prof.S.V.Lohar, working as assistant professor at Institute of Information Technology. I'm going to talk about attenuation measurement. Microwave components and devices almost always provide some degree of attenuation. So attenuation is the ratio of the input power to the output power, and it is normally expressed in decibels. Attenuation in dB is equal to 10 log of P in by P out, where P in is input power and P out is output power. So we are going to discuss two methods to measure attenuation. First one is the power ratio method and second one is the RF substitution method. Power ratio method. In this method, we are measuring input power and output power with and without device whose attenuation is to be measured, as shown in the setup 1 and the setup 2. In setup 1, we are measuring input power P1, and in setup 2, we are measuring output power P2. The ratio of these two powers expressed in decibel will give you attenuation. So this is the setup number 1, which will measure the P1 watts, that is the input power. So setup is like this: microwave source that will generate the microwave frequency, pad is nothing but the attenuator, frequency meter will for measuring the source frequency, then slotted line is in order to accommodate the crystal detector, probe of the slotted line is connected to the crystal detector, and another end of the one end of the waveguide of the slotted line is connected to the match termination. Then crystal detector is connected to the thermistor mount, and thermistor mount is connected to the power meter. This setup will measure the input power. So setup 2 will measure the output power. Same setup we are using that we have used for the setup 1, and only difference is that the device whose attenuation is to be measured is connected in between frequency meter and the slotted line. The drawback of this power ratio method is that the attenuation measure corresponds to the two power positions on the power meter with the square law crystal detector having the characteristics shown in the figure. So due to this non-linear characteristics, two powers measured and the attenuation calculated will not be accurate, particularly if the attenuation of the network is large and if the input power is low. So this drawback is overcome in the second method, that is the RF substitution method. This method consists of the measuring the output power, say P, including the network whose attenuation is to be measured. That is used in the setup 1. Here we are using the same setup for that we have used for the first method. So here we are using the network that is inserted between frequency meter and the slotted line. So in setup 2, network is replaced by the precision calibrated attenuator, which can be adjusted to obtain the same power P as in the setup 1. Under this condition, attenuator read on the precision attenuator will give the attenuation of the network directly. So in this way we can overcome the drawback of the power ratio method. Thank you.